All right, this is going on page 92 when we are done. So if you remember, hey, I'm over here. If you remember when you first learned trig in geometry, we only did it with right triangles. And you were told, right, you can use trig for things that are not right triangles, but right now all you know is right triangle trig. So as far as you're concerned, it was only right triangles. So now we're going to get into some triangles that are not right triangles. And the first thing we're going to use is what's called the law of sines. And we're going to come up with the law of sines together here. So here's a triangle. The angles are labeled with a capital A, B, and C. The side lengths are labeled with the lowercase a, b, and c. And notice that A is across from A, B is across from B, C is across from C, right? So if I needed to find a missing side or an angle on here, I couldn't do trig as you know trig here. I can't do, SOHCAHTOA does not work on this. So in order to come up with the law of sines, I'm going to take you through the process of where it comes from. We're going to need the height of this triangle. So I'm going to draw in the height right here. When I do that, that creates two little right triangles. Make sense? Okay, so one thing I can find using the trig I know how to use is the height of the triangle. So I can do that with angle A, right? If I look at angle A, the height is the opposite, and then the hypotenuse is B, right? So I can write down that the sine of A is equal to the opposite, which is H, over the hypotenuse, which is B. You can write SOHCAHTOA at the top if you want to. All right, so then I could also, instead of using A, I could have used B. So the sine of B is opposite over hypotenuse, so that would be H over A. So I'm going to write that one down as well. So the sine of B is equal to H over A. Okay, so do you agree with both of those things? So what we're writing at the top, I wouldn't expect you to recreate. It's just where it comes from. So as long as you can follow me and the math makes sense to you, then you're fine. Don't think this isn't like how you actually use the law of sines or anything. So these two equations, what do they have in common? They both have a height on them, okay, and they're both in sine, okay? Well, yeah. But they have this is angle A and that's side A, so they don't really have that in common. But they both have an H in there, so it's the same height, right? Different angles, different side lengths, but the height is the height. So if I take both of these and I'm going to just solve for the height, which is pretty easy to do, right? So on the left here, I can just multiply both sides by B, so I'll get that the height is equal to the sine, let me not write it like that. H equals B times the sine of A, which is what I meant to write. And here, H is equal to A times the sine of B. Okay, everybody okay with all that? So since they're both equal to H, I can do some substitution here. I can take this right here and substitute it in right here for H. You agree with that? Okay, so then that's going to give me B times the sine of A is equal to A times the sine of B. All right, so now I'm going to clean this up a little bit. I'm going to divide both sides by little b so that these cancel out, and I get the sine of A is equal to A times the sine of angle B over B. Everybody with me? Then I'm going to divide both sides by A so that those cancel out. So in the end, what I have is that the sine of angle A over the side length A is equal to the sine of angle B over the side length B. Okay, so it's a nice little proportion that's pretty easy to remember. Okay, because A goes with A, B goes with B, and there you go. Okay, make sense? Now, which triangles can we use this on? Because we can't just use it on every triangle that's not a right triangle. It only works on certain ones. So what this says here, it says, previously you learned how to solve a right triangle. We will now look at how to solve an oblique triangle. All that means is that it's not a right triangle. And we're going to use the law of sines. Okay? So the law of sines can be used to find the side and angle measures given two angles and any side with these. So in geometry, we prove triangles congruent, right? And we have postulates and theorems to do that. What you need to glean from that to be able to use this, we're not proving them congruent. It's just the setup of the triangle. What information do I have? So angle, angle, side, or angle, side, angle. Those are the ones that we get to use law of sines for right now. So if you look at this triangle in number 1, the information that is given to you, you have two angles in the non-included side. Two angles in the non-included side means that this is angle, angle, side. Make sense? This is two angles and the included side. So this is angle, side, angle. So those are the two right now that we can use for law of sines. Then it does say or two side lengths and an angle outside them, this SSA. Were you allowed to use that in geometry to prove triangles congruent? No, because there's no ass in geometry, right? So we're not proving them congruent. But if you have this set up, there is a little caveat to that, which we're going to talk about this one on Monday. I split these notes so that we would have time to talk about your course selection again. So we're only going to look at the angle, side, and the angle, side, angle today. On Monday, we will look at the side, angle part of that. So still not proving triangles congruent with it, but we can use the law of sines to find missing stuff. There's just a lot of special cases there. Okay, so those are two that actually worked to prove triangles congruent. What are the other ones that we used? Do you remember? Side, angle, side. Did angle, angle work? No. Because if I had a triangle that I drew like this, then these three angles could be congruent to these three angles, but the triangles aren't necessarily congruent. That works for similarity, not for congruence. What else besides side, angle, side? Side, side. No. No, because that's the same as that one. All right, so there was one that had two letters, and they're not any of these letters. Remember that? No, not any of these letters. H what? HL for hypotenuse leg. This is the one that worked. This is when side angle worked with right triangles. Because side angle would work with right triangles. It was just called hypotenuse leg because it only worked with right triangles. Well, since this has to be a right triangle, and we already know how to do trig with right triangles, that's not even going to ever be an option. These two we're doing today. This we're doing on Monday. That's all the law of sines. These two go with what's called the law of cosines, which we'll do after that. Okay, but it's still just, you've got to make sure you can understand the setup of the triangle. So if you are going to use the law of sines, what we came up with up there was that the sine of A over A equals the sine of B over B. And if we turn the triangle, and I could take you through where it comes from, or maybe you can just trust me that this would happen, the sine of C over C. You wouldn't use all three at the same time, because to do a proportion, it's only two at a time, but that's a true statement there, so it doesn't matter which set you're using. Plus, most of the triangles, like the ones we have here, they're not even labeled A, B, and C, right? So it doesn't even matter. What you have to make sure that you understand is that this angle, like if this is going to be angle A, then this is side A. The angle and the sides are across from each other, and that's what you're matching up. Okay, we good? All right, so let's look at number one. So I have two angles in the non-included side. That makes that angle, side, right? And I'm going to draw arrows. This angle goes with this side. This angle goes with this side. So to be consistent, the first fraction I'm going to set up is the one that has all the information I need in it, like there's no variables. So that would be using this 47 and the 15. So I can say that the sine of 47 over 15 equals, and then the other angle I have is 104, so the sine of 104 over the side that's across from it, which is x. Okay? And then you just solve the proportion. So if I cross multiply here, I get x times the sine of 47 is equal to 15 times the sine of 104. So x is equal to 15 times the sine of 104 over the sine of 47. Now, let's look at our calculators before you start typing in case somebody got bored after final exams and was playing with them. Okay. What?
The x can't switch positive and do that right?
No, that's different. Well, yes, it can, but then you have a fraction, and a fraction that isn't what it ends up happening. So you would have the sine of 104 over this right here, and then you flip and multiply. So you can do it as long as you do it correctly. Yeah. I don't know that everybody would want to go down that road, but if it makes sense to you, it's fine. All right, so turn on your calculator. Make sure it says degrees at the top, that little tiny letter D that's kind of hard to see. And then also make sure it says math at the top. Okay, everybody have that? We're in degrees and we're in the math mode. Okay. Does it really? Because it can. Yes, that's why I'm asking. It's not a stupid question, okay? I can say a lot of things up there. All right, so on these calculators then, hit the fraction button, which is under calc, and then type 15 times the sine of 104 in the numerator, sine of 47 in the denominator, and get your answer. Shift mode 3. Mode is up at the top. Mode 3. And then you're not in math either. So that's one reason. So you have to hit math mode 1. And does it say D? Okay. 19 point what? 901 centimeters. Thank you. Okay. We all good with that? Yes. All right. So now let's look at number 2. This setup, this is 2 angles in the included side, so this is angle, side, angle, right? So it still works for law of sines, but when I draw my arrows here, this angle is across from this side. This angle is across from a side that I don't know, and this side's across from an angle that I don't know. So what's going to be easier for me to find to move forward, this side or the angle? The angle, yes. How do I find the angle? Add them up, subtract from 180. Okay, so make that happen. Tell me what it is. 75. So this is 75 degrees. So now I have this angle across from that side, and 63 isn't part of my work. I needed 63 to get me to 75, but that's not what I'm matching up. Okay. So now I'm going to have the sine of 75 over 28 equals the sine of 42 over x. And then just solve that. I'll let you finish that one. Because I don't have a side across from it that I'm looking for or that I have. Okay. The only reason I would use 63 is either if I had the side across from it, so I needed that in the equation, or if I'm looking for it. So I could use 63 and I could find that side, they just didn't ask me for it. Okay. We good? Yes? Okay, awesome. All right, so any questions so far? Because we're not going to do 3 and 4. I mean, I think one of each of those, and then this one I think will probably be good. Okay. All right, let's look at number 5. Says a pilot begins a flight traveling 80 miles northwest to avoid a storm. He makes a turn, then returns to the original location. A diagram of his flight course is shown to the left. Find the total distance of the flight. Okay, so he starts here. He flies 80 miles, he turns, he comes back. If I want the total distance he traveled, then basically I want the perimeter of the triangle, right? So I need to find side lengths. This is going to be x, this is going to be y. So in the end, what I'm going to do, since it says total distance, I'm going to need to take this 80 and add it to x and add that to y. And I'm writing that down for myself so I don't forget to actually do that in the end. So since I need so this 108 is across from x, right? This 80 is across from this angle that I don't have, and 15 is across from y. So right now, I just have 2 variables, so I need this angle, right? What is this angle right here? 57 with a question mark. Y'all agree with that? Yes? 57? Okay, there you go. You do have calculator. Oh, I did mine. It doesn't matter which direction you do your arrow in, but I'll just be consistent, so let me fix mine. Oh, I'm on board. There we go. They both what? Okay. Very good idea to draw, when it's a very stretched out triangle like this, to actually draw the arrows so you use the correct side angle combination, which seems very simple, but it's also very simple to mess up. I know because I messed it up last period. So not a bad idea to do that. So the 2 pieces that match up, I have an angle and a side with this 57 and this 80. So I'm going to have the sine of 57 over 80. And then we'll go for x first. So then that x goes with 108. So I have the sine of 108 over x. Okay? Everybody okay with all that? So I'm going to get x times the sine of 57 equals 80 times the sine of 108. x equals 80 times the sine of 108 over the sine of 57. And then,
Are all three sides and like
yes. Okay. You could. I'm just going to pause right here. I'm not even going to type it in the calculator right now. If you did, you want to store it. Absolutely. Okay. Then let's move on to B. So I'm going to start with the same information I had. Even though maybe you typed it in and you have x now, I wouldn't use it to find the next one unless you absolutely have to. I'm going to stick with the sine of 57 over 80 is equal to, so my other angle is 15, so that's the sine of 15 over y. So then that gives me y times the sine of 57 equals 80 times the sine of 15, and then y equals 80 times the sine of 15 over the sine of 57. Okay, so you got a couple of options here. And which options you choose depends on just what you would prefer to do and probably what kind of calculator you're using when you're doing it. Using these calculators right here, it would be very simple to use that fraction button and just add this plus 80 and get it all together, and you wouldn't have to type them in and store them. However, I actually like getting the actual answer and storing it, and here's why. So if you do get x, you get x equals 90.72 something. Now, anytime I put the ... that's telling me, I mean, you can do whatever works for you, but that tells me that I stored that. I would never go back and type that number in. That's why I'm not even writing the whole thing. Your final answer will never have a ... on it. Some of y'all do. I don't know. Clearly, you don't understand what the ... means. So that's just saying that's 90 point something in there. And then when I type in y, I get 24.68 something, right? One of the reasons that is nice to have is so you can actually look at reasonableness here. This is about 90, right? This is about 24, and those seem like reasonable numbers because if this is the biggest angle, this has to be the longest side. Like if this was less than 80, then something's wrong somewhere. So sometimes seeing the numbers, even if you don't compare them, if one of them was negative or one of them was like 1,800, like something would catch your eye more so than if you don't even see what the value is. So either way, whether you do this and you store it, or you type in the fractions and you add it to that, in the end, you should get that your total distance is what? Good. Miles. That's right. Okay. Everybody good with that? Okay. All good? All right, so flip this over. We're not actually going to we're going to draw one thing on the back. I'm not even going to talk about the words or anything yet. I just want to let's look at the picture for number 6, okay, because it's not drawn there for us, so we're going to draw it. So I'm going to draw and label this picture. So we're going to draw a triangle. I don't even know what the triangle is supposed to look like, so just drawing a triangle that you can label is fine. Then I'm going to label it A, B, C. So angle A is 60 degrees. The length of AB is 30 inches. The length of BC is 27 inches. And I am looking for theta. I'm looking for angle C. That's where I'm going to put my theta. Okay, so for any of these, if you're like, okay, I'm going to have to use trig, it's going to be a law of sines or cosines, then I need to decide what information I have. Well, they gave me 2 sides and an angle. This is 2 sides and a non-included angle. So this is a side-side angle situation, which means it is the law of sines, but not the law of sines we've done yet. Does that make sense to you? There is. We're not in geometry. Okay? And we're not proving triangles congruent. You can't use it to prove triangles congruent, but it's here. So even though we only have those 2 that we can actually do so far, you always want to check that because once sine and cosine get mixed together, that's how you're going to determine which ones you use. Okay? So if you get one of these on I'm telling you this because I split the notes and I didn't split the homework. So I'm going to go ahead and give you the assignment. There's a lot of it on there that you can do. Go through and determine if it's angle, side, angle, angle, side, or side, side, angle. If it's side, side, angle, you skip it for now. The other ones you do. Okay, don't mark them out, just skip them. I don't even want you to do anything with them. So that means on the ones where you have to draw the pictures, you can go ahead and draw and label the pictures because you're going to have to do that anyway. And then if it's side, side, angle, then you just don't work it and you just move on, then your picture's already there for you. Okay, does that make sense? That way you can just get done whatever you want to get done. Okay. Monday.
Oh, yeah.
There's a lot of special cases that go along with this that we need to talk about. It is, but there's little things that you have to take into account that doesn't make it as easy. Okay. All right.